Hello. This video is about functional groups. In organic chemistry, a functional group is a group of atoms or atom that really defines the organic molecule. This is where reactions are going to take place, and this is what allows us to name different molecules based on a functional group. A couple examples. So that nitrogen bond to a carbon, double bond O, that's known as an amide group. We have here this carbon that's not shown bonded to the oxygen, bonded to another carbon. That is an ether group. And this is a hydroxyl group. And so we're going to see these different functional groups and how they allow us to properly name molecules. So single bonded functional groups are joined to a carbon chain by a single bond. So here's a carbon bond, the hydroxyl group, so that's an alcohol ending of OL. Here's a nitrogen single bond C. There's also a nitrogen single bond C on the other side. It's not two different groups. That's an amino group, and we have amines when we have single bond N to a C. And finally, this is the functional group. It's an ether group, and methoxymethane is an ether. First group we'll talk about are the haloalkanes. This is when a halogen is bonded to a carbon. It could be an alkane, alkene, alkyne. So the molecule is going to be classified as a haloalkane, and the functional group is a halogen. So here we have carbon bonded to chlorine. So how do we name this? The longest chain is an ethane chain, so it's just ethane. And the halogen is treated as a branch, and so that's just chloroethane, and that should be one word. No numbering is required because if the chlorine was on this particular carbon, it would simply be carbon 1 again, and it would still be chloroethane. In this case, we have a 3-carbon molecule, so that is a propane, but we have 2 different halogens. Now we minimize position, so we're going to start numbering from here. So there's my numbering for the carbon. So on carbon 1 we have a fluorine, on carbon 2 we have a bromine, but we list them alphabetically. So this is going to be 2 bromo, 1 fluoro, propane. Halogens be classified as primary, secondary, tertiary depending on the number of carbon atoms bonded to the carbon atom that is bonded to the halogen. So here's the carbon atom bonded to the halogen, a fluorine bonded to this carbon. This carbon is bonded to only one other carbon. So that is known as a primary haloalkane. If you look at the second example, here's my carbon bonding the fluorine, and the carbon that contains the functional group is bonded. The functional group is bonded to 2 other carbons, so that is a secondary haloalkane. And finally, here's my carbon bonding the fluorine, and I have 1, 2, 3 other carbons bonded to it, and so this is a tertiary haloalkane. 2-fluoro, 2-methyl propane is a tertiary haloalkane. Second group of the alcohols contain the hydroxyl group, OH group. So the molecule is classified as an alcohol, and the functional group is called a hydroxyl group. Now the OH looks like a branch, but as soon as you see an OH group on a molecule, it's an alcohol, and that's going to dictate the name. The naming is really quite straightforward. We look to the longest carbon chain. Here's an ethane chain. So that's an ethane, except we take off the E of ethane and we add OL. So that's ethanol. Sometimes you have to number correctly and position the alcohol, the hydroxyl group on the alcohol. So in this case, I would number it this way because I see that the OH is closer to this end, so that's on carbon 2. It's a 4-carbon chain, so that's butane, except we're going to add the 2-ol. So it's butanol, but on carbon 2 we have the OH group. Butane 1-ol would be an isomer. Alcohols can be classified the same way as haloalkanes, depending on how many carbons are bonded to the carbon bonding the functional group. So there's the carbon bonding the functional group, bonded to a single other carbon only. So ethanol is a primary alcohol. Propane 2-ol is a secondary alcohol, and 2-methylbutane 2-ol is a tertiary alcohol. So alcohol classification is pretty much the same as haloalkanes. Ethers are the next group. Ethers have a functional group that is considered to be a carbon bond oxygen bond carbon in the chain. So here we see the oxygen bonding within the chain. So that's distinctive of an ether group. Classified as ethers, and the functional group is called an ether group. Naming is a little different. We look to the longest continuous carbon chain on one or the other side of an oxygen. So in this case, there it is, and we give that an alkane name, so that's simply ethane. And we treat the rest of the molecule, including the oxygen, as an alkoxy branch. So an alkoxy branch is an alkyl branch with an oxygen. How long is that branch? Well, it's a methane or a methyl branch, so that is methoxy. So methoxyethane contains a methoxy branch attached to an ethane molecule. Similarly, here's my longest continuous chain, and that is a propane, 3 carbons, and attached to my propane I have this ethoxy branch, but it is attached to carbon 2. So it would be known as 2-ethoxy propane. Amines are the final single bonded functional group we're going to look at. These are distinctive of an N bond R, and that R needs to be at least 1 carbon. And so an R group is simply a carbon containing group, so we do need a single carbon attached at least. So here's an example, carbon bond N, single bond N. So this is an amine. Classified as amines, the group is an amino group. So once again, if we're looking to name it, we recognize the longest chain, which is in this case an eth, and so we just add an eth and prefix. We take off the E of ethane and we add amine, ethanamine. So in this case, we have a butane root name, but on carbon 2 is my amino group, so this is going to be 2-butanamine, amino group on carbon 2. Now, you can also have primary, secondary, tertiary amines. The examples on the previous slide were both primary amines. Now we have an example of a secondary amine. And if you notice, the view of it is a little different. Here's my nitrogen, and it has 2 distinct R groups attached to it, hence only 1 hydrogen. So that's a secondary amine, and to name that, we just look at the branches and list them alphabetically as alkyl branches. So this is ethyl, methyl, amine, and you will sometimes see the second, whatever the branch is, the second one put in brackets, I guess to distinguish between them. I'm not entirely sure why. In this case, we have, that's a butyl branch, that is an ethyl branch, that is a propyl branch. So this molecule will be butyl ethyl propyl amine. So naming of primary, secondary, and tertiary amines is a little different, but secondary and tertiary is really just looking at everything as alkyl branches. So here's a few more examples. This is a haloalkane because of the presence of chlorine. It's a 3-carbon branch and it's on carbon 1. So we do need to position that chlorine. So 1-chloropropane. Here's a 3-carbon alcohol. Once again, we have to position that hydroxyl group. So that's going to be propan-1-ol. Again, positioning required. Here's an ether. So my longest branch is a 2-carbon branch, so that's an ethane, and I have a methoxy branch there. So methoxyethane. And here's a primary amine, 3-carbon branch with an amino group, so that's just propan-1-amine. I need to position it because propan-2-amine is an isomer. Finally, here's a secondary alcohol, carbon containing a function group bonded to 2 other carbons. I need to position that OH group, that hydroxyl group, and so it's going to be on carbon 2 of a 5-carbon chain, pentan 3L, carbon 3. And finally, this looks a little complicated, but there's a cyclic pentane with an OH group, so that's cyclopentanol. That's going to be carbon 1, and so I have a branch on carbon 3, and that is an ethyl branch. So 3-ethyl, cyclopent, and 1-ol. So that's an introduction to functional groups.